one of the big discoveries in the last 2 years has been the realization that with topological insulators, one can carry out experiments that are at room temperature, so under ambient conditions where you expect technology to work. You can measure phenomena associated with these special surface states of the topological insulators. And we know that the spin associated with these surface states can now be used to manipulate the magnetization, for example, of a ferromagnet.
This is a new field of research on these topological insulators. This topological insulator has been described sometimes as a new state of quantum matter. And so with is really new property, unique properties. And it's very exciting to explore this new field. For example, we have seen wonderful results of these materials, the topological insulator, for the conversion between charge and spin current, that is for the creation or detection of spin current in spintronic device. And so we have seen the potential of this, and we have seen also that now the technology allows people to fabricate very good materials, and so a large field of research is open with certainly interesting application.
Topological insulator, I think the beautiful part is robust, so it's prone to the defects, and that was being discussed by physicists, and from this workshop, we can see a lot of evidence along that line, and then some exciting, transmission electron microscope pictures show those materials can grow well on all kinds of different substrate, and that's very exciting in that aspect. Topological insulator could be much better for certain application than MTGF. Okay. But for some applications like memory, MTGF maybe still could hold the better position for a little bit longer, but you never know. There is a new physics always come out. At the conference, we talk about some new reading scheme based on the new physics, new discovery, and then that may change the how people view the building blocks. Maybe MTGF in 10 years, maybe not the best building block for memory anymore.
The fact that that the functionality is supposed to come from the surface, and we all know that surfaces of materials, they're exposed to ambient conditions, they oxidize, they react to the environment. And so the question is, in a manufacturing sense, so in a sense of making devices that can be made in the, at a large scale with, millions of such devices, how do you develop a protocol that would keep these surface states intact and so on, and survive for sufficient time to be a useful device technology? I mean, those kinds of pragmatic issues are still big challenges that remain to be resolved.